Hi, guys, and welcome back to another episode of Women in Math and STEM, where our mission is to reach out to as many professionals, aspiring professionals, students, whatever you name it. We try to reach out to them, who essentially support the initiative of bringing more women and young girls into the STEM field. So, with that being said, as always, feel free to open up the description or transcript to better follow along, and I hope you enjoyed this episode. Hello, and thank you so much for being able to come to this call today and talk with me. Just to begin, if you don't mind, could you briefly introduce yourself as well as sort of explain how you got to where you are today?
That's my pleasure. So my name is Bruna Shinohara. I have a PhD in physics, where I specialize more on material science. It had some connections with quantum computers, which is what I work now. I am now a staff scientist in a company in Canada, where I do more like software side of quantum computing.
What sort of got you interested in material science, physics, and quantum computing?
Uh, it was kind of a journey because I first started in physics. I was not even sure that I wanted to do physics. Back when in my country, in Brazil, I had the possibility of do kind of like a science undergrad. That after that, I could choose some of like my minor. I think that would be the equivalent for the US. And I kind of wanted to do biology, but not really. My parents are like, "Oh, you should do biology. You like marine animals." I was like, "Yeah, sure, whatever." And then I noticed that was not really my thing. But then I took physics one with a very nice professor. So that was the first time that I actually had a different perspective, like a more profound perspective in physics. So that's how I got into physics, kind of by accident. And then when I started doing my undergrad, I was like, oh, I like this. I don't like them that much. But what I noticed that I really like quantum. Quantum was the topic that really caught my attention during undergrad. Although I started researching plasma physics, which is a different topic, got me interested because I was a bit interested in nuclear fusion, which has something to do with this, but it's not quantum at all. So when I noticed, okay, no, I actually really like quantum, then on my master's, I changed gears and I went for more of a quantum route. And at that point was not quantum computing or material science, but it had some elements to it. And I started hearing about it by my advisor, other people. So after the 2 years of master, I was like, oh, I think I want to pursue more this direction. And then I pursue my PhD with a professor that he's in material science, but he had this proposition that start to merge with quantum computing. And then I start to really looking into it, and that's something that I really noticed. Okay, it's quantum. It has all like interesting element of being a very new topic. Things are happening every week. You have news all the time. So yeah, it was an interesting choice for my PhD. I changed kind of the topic 3 times, but that was the one that was like, okay, I like this.
What's been the most difficult part and the most fun part about pursuing a degree in physics, especially like the fact that you've gone so far and changed your um
Yeah.
idea so many times for your PhD? That's really cool.
Yeah, for me, I was not super prepared because um, I didn't have anyone in my family or my social circle that was in physics or even scientists. So when I started and I decided to do this, it was like a very wild idea. People are like, "Are you sure you don't want to do engineering, something that people know what it's about?" And well, because I never considered that during my high school, I thought physics was my worst topic. I didn't really went through in depth in it. So I have to really compensate for that. For me, the first year, And second, I'd say, which was the transition when I noticed, okay, I want to do physics, I need to take this serious. That was hard because I really have to compensate for my math and my physics. That was not the best. Just in part because my professors didn't went too much in depth. I didn't have any labs for physics or for chemistry. And because I was also not interested, so I have to catch up with this. It was hard and a very steep learning curve, but after that, I think things improved quite a bit. Eventually, you learn how things go in physics, and it got easier.
And then if you don't mind me asking, I feel like this is kind of like a fun question when I talk to people who have a background in quantum. Where do you see quantum computing in like the next few years or like in a decade or so, based on your experience?
Oh, that's a hard one. It's I'd say there are some people that are very optimistic. If you look, for instance, some companies have roadmaps what they think the hardware will be in certain years. And IBM, for instance, is very optimistic, saying that 2030 we'll have a computer that it's pretty much just solve the errors, the issue with the errors, which is one of the big limiting factors. And it's gonna scale a lot. We're gonna have everything that we need to do with like the biggest computations and surpass traditional. I don't think it's gonna be like that, but I think we're gonna surprise ourselves mostly because there are many people working both on the theory and having nice results, especially looking at new ways to how to fix the errors or deal with them. And people looking at different hardwares, and people looking at superconducting, people looking at trapped ions. And even if there is progress in one hardware, it's not yours, it's not what you're looking at, this progress may help you. So I think those things add together to eventually we can get very some leaps of advances in quantum technology. And I am optimistic that we're gonna figure out at least we're gonna have for sure more qubits and be able to scale and at least find new ways to deal with errors. Probably not as optimistic as people think, but there's also the issue that there's a lot of money being invested in this, and the money itself already helps accelerate a lot. I would say we're gonna have progress, but not in things that people would so people really go, oh, quantum will merge with AI and have like intelligence, human intelligence because of quantum. So that's when it gets very sci-fi for me, because we also have a bunch of obstacles to surpass to integrate artificial intelligence and quantum. So I'd say we're gonna have for sure progress in hardware and software and the theory that is gonna lead to nice results, but I don't think we're gonna scale to have whole AI or break encryption, all those things that people consider to be the end goals for quantum.
And then I was also curious about sort of your favorite areas of research in terms of like physics as well as quantum computing.
Okay, for physics, there are many things in physics that I'm interested. The thing that really catches my attention in physics is everything that is now intuitive. That's why I like quantum. I think quantum has a lot of things that you really need very specific experiments and look at the maths to really understand what happened. And you can find some of these non-intuitive things even in more basic things like thermodynamics, electromagnetism, things that you can actually see in your day-to-day. And you think, okay, we figure it out, but sometimes you find very weird stuff going on. So I always like to look at those weird stuff just across all the physics. So you can find this in relativity, you can find this in quantum, you can find this in pretty much every area. There's also the frontier between physics and philosophy, which I think is interesting because sometimes we have very good mathematics for some stuff to describe the nature. So we know how it happens, but sometimes we don't know why. And that's the question, like, why the universe was like this in the beginning? What are the possibilities from that? Why quantum behaves this way rather than how, because this is solid enough. But if you go and actually talk to people looking at this area called quantum foundations, they are actually diverging in some of the whys, some of what really means this thing that we're looking at, we know and we can predict and we can describe, but we don't quite agree on what really is happening, which I think is interesting. That's very, very intriguing. Not really my area, but I think it's very intriguing. And about quantum computing, for me in particular, I like to learn about the computing side of it, because I have all this trajectory in physics, and quantum computing merges both things, especially if you look at more theory side and not experimental. And for me, it's a brand new stuff, right? I have some familiarity with computing because, well, I had to program on day to day, but it's not like I know the theory of computing or computation, right? So for me, it's kind of going back to undergrad at some point. Things that are basic for the undergrads in computer science are not basic for me. And I feel like I'm having a new opportunity to learn new stuff. It's exciting.
And then, sort of, finally, do you have any advice, recommendations, or suggestions for students, especially like young girls and women who are interested in pursuing physics or quantum computing in the future?
I'll say, I think that's valid for young people, but I'll for sure make it even more, I think that's even more important for women, is that you should try to find mentors and not be afraid to reach out to people that you believe to be more senior, that has something to add, or something that is going in the path that you want or you vision. Because, and this is something that I noticed as I was progressing my career, I noticed that more people are reaching out to me to ask, oh, how do I get into quantum? How do I do a PhD? That's fine. And I try to help, but the overwhelming majority were men asking me this. And of course, I'm like, of course I can help. And I understand there is still like less women pursuing STEM. But I know there are women that don't go and ask stuff because they are afraid to just to bother. I know because I was like that, and I still am like that. And sometimes I reach out to younger people, and they're like, yeah, for sure, I like to help, but I didn't want to ask. Like, you can ask. You can ask people more often than not. If you are kind with your request, they want to help, and they want to try to talk about what worked for them or not. The other thing is just keep your eyes open to different paths of career. For me in particular, as I said, I come from an environment that there was no scientists in my day-to-day. So it's something that I wouldn't consider until I was put in an environment that I saw the first physicist of my life. I was like, okay, this is actually a job that I can pursue. So if you can put yourself in situations like career fairs or any events that you can actually go and see a professional, just to see how they talk about their day-to-day, and you can actually visualize yourself there, I think that can change completely your outlook and your view, or even for you to say, okay, I don't like that, I don't want this. This is actually pretty relevant, because sometimes you're like, oh, okay, I think I like biology, and then you don't. So, and those are small things that just reaching out to the right people you can avoid without really, okay, I need to learn this. Just Yeah, reaching out to people goes a long way, I'd say. Let me see about quantum in particular. Quantum computing changes a lot, so right now it's rapidly changing. So if you can keep your eye on the news, this is good. But also, I would recommend uh, try not to funnel yourself too much in a corner, be like, oh, I'm a quantum computing specialist, because there's a bit of a risk involved. This is emergent tech. And as emergent tech may go through cycles of hype, it happens to AI 2, 3 times at least. So there's the issue that if you over specialize in AI or another tech, quantum, and you start have a decrease of interest in this kind of professionals, maybe you have an issue to find a job. So I would say for practical purposes, as much as I like quantum, try to be broad in your abilities that you try to cultivate. Try to be a professional that can adapt to this kind of things if you're looking to work for in a emerging tech kind of thing. That's why I myself, and that may vary, but I think if you're interested in that, you better pursue either computer science or physics. So you have a background in those broader things, then go straight to quantum information, for instance. I think it's just a bit safer.
Ellie, thank you so much for coming to the call once again and talking with me. It was phenomenal. Thank you.
It was nice. Thank you for inviting me.